Hello everyone, welcome to the course on finite element analysis using Ansys Workbench. In this session, I will be taking you through the Ansys Workbench environment and how to get started with the Ansys Workbench and the graphic user interface that will help you to get familiar with the working environment of this finite element analysis tool, that is Ansys. We're going to discuss about the project page layout, different regions that are available in the interface, how to work with graphic user interface, and what is the standard workflow defined by Ansys for solving any engineering problem. The workflow that we can get to see now in the Ansys Workbench was not there a decade before. Ansys has evolved drastically and has made the user experience much simpler. We are going to witness that in this session. First, to begin with, I will take you through how can we get started with the Ansys Workbench. First, we are going to start and type here Workbench. If you haven't installed Ansys Workbench in your machine, then please see my previous video of how to download and install Ansys Workbench into the machine, where I have clearly defined what are the system requirements and limitations of the student version of the Ansys, and also what all is included in this package. Click on Ansys Workbench 2022 R2. This will open the application. This may take some time to open. Yes. This is how the home page of the Ansys is going to look like. We have launched Ansys Workbench successfully. Now we understand about the analysis systems and the project schematic. On the left hand side over here, there is a toolbox wherein we get to see the analysis systems. When we say analysis systems, when we solve the engineering problem can be put into multiple categories like structural analysis, modal analysis, buckling analysis. It can be a harmonic analysis, rigid body dynamic analysis, explicit analysis. These all analyses are categorized as analysis systems. So for example, if we want to understand a deflection stress behavior of certain object which is subjected to structural load, then the most commonly used analysis system is static structural. We press hold on this and move it to project schematic over here. This white window is the project schematic window wherein we can create multiple projects and relate them. For example, we are going to conduct a analysis for analyzing the behavior of the body due to structural loads. We also want to understand the natural frequency of the body, for which we conduct the modal analysis. Press hold and move it to the project schematic. We can add as many number of projects required for this project schematic. This is one of the key feature of the Ansys, that multiple problems can be solved in the single environment. By default, these projects will get the name A, B and C. Right click on the static structural, click on rename. We can give name for this one, let's say beam. We are going to solve for beam. Model analysis, right click on this rename, we can give it as a frame. And static analysis, again right click on this, click on rename, we're going to give the name for this as bolt. If we want to have a description about this particular project, right click on this and say here add note. We can write a note for our summary purpose. Similarly, right click on this model analysis and click on add note. This is going to give a quick summary of the status of this particular project. It is kind of a sticky note kind of a thing which is embedded into these projects. This is how multiple projects can be created in the project schematic from the analysis system. Let us say we are creating one new static structural analysis, but which requires the material same as project A. In the project A, we have defined, let us say, 4 specialized materials which are developed by some organization which is not available in the library of Ansys. So when those new materials are defined here in A, which we want to reuse in the project D, then we can press hold and pull that data to the project D so that the material information from this project to the project D will be shared. So whatever material data that is available over here will be made available for this system. If at all you have solved a beam problem here and here right click rename, this problem may be a disk problem. Even though geometries are changed, the material information is going to be the same. This is one of the flexibility that must be appreciated for Ansys. With having understood about the launching of the Ansys Workbench, analysis systems and the project schematic, we also understood about how to create the project, and we also discussed about the project name and description. And we also saw how the data can be shared from one file to another file. We'll talk more about this data sharing when we take up the examples in our next sessions. With this, we will move on. Now it is a time for us to understand the Ansys mechanical environment. So first we are going to understand the different regions that are available in the environment. I will show you. Before that, we have to understand over here. The first one is the context. I'll explain what is the context. Next are the tabs like automation, selection and display. This is the graphics window, and these we call as a ribbon. And on the right hand side, we have the toolbars and the layouts. Here is a tree outline, the details and the status bar. We'll click on the static structural and take it over here. Right click on the geometry and click on import geometry. We use the recent file that is crank. Right click on this file, rename that and type it as a crank. Double click on the model. This will open the geometry in the mechanical environment, which is easy for us to interact with the different regions and the toolbars. The Ansys mechanical window is opening. It may take some time to load the geometry. Yes, the crank geometry is now loaded into the graphics environment. Just press hold middle mouse button and move the mouse. This rotates the geometry. press hold Control, press hold middle mouse button and move the mouse to pan the geometry. Press hold Shift and press hold middle mouse button and move the mouse to zoom in zoom out, or just scroll to zoom in zoom out the geometry. Now we'll understand more about this different regions. Top here we can see something called as context, which is going to change when we click on any of the tree items over here. So based on these different selections, the context is going to change. We can see how the context is changing. Basically, the environment is changing when it is being selected. These are the pull down menus or tabs: display, selection, automation and add-ons and so on. And this is the tree or the tree outline, which is going to maintain the history of whatever the activities that we do to build the finite element model. Now these windows, we can click on them and move it wherever we want to move it. This is going to disturb the environment. We can reset that by clicking on the home and come here, click on reset layout. All those things will be set now. Whenever we click on the individual line items in the tree, at the bottom we get to see the details of that particular selection. Let's say we have selected a crank. We can get to see the details of that particular geometry. The material assigned to that is structural steel, and the graphics properties, this is visible, which we can make it as invisible as well. Transparency can be changed so that it becomes transparent. Right now we keep it as opaque. Color can be defined as we desire. We click on that particular geometry and we can change the color. Similarly, we can define or set the stiffness behavior for this. Click on the crank again. We also get to see the properties like the volume, mass, centroid and moment of inertia. When we click on the materials, the structural steel, the specific details of that material details also can be seen over here in the details. Now right click on this mesh and generate the mesh, and we apply some structural load to that. Let's say force we want to apply to this particular face. On the details we get to see if at all a force has to be applied, on which part of the geometry it has to be applied. We selected the face. Similarly, whether it has to be defined by the components or it has to be defined by the vector, what would be the magnitude of that has to be defined over here. Once it is defined, we also get to see the details of that particular boundary condition or the load. This is the way we make use of this details tab here. Then whenever we click on any of the command, like let's say we want to apply a pressure, the details of the pressure also is going to come, and at the bottom we have something called as status bar, which as we go on working is going to display the status. These are called as the ribbons, which we're going to make use one by one or as per the need when we solve the problems. Now we will go in depth about the GUI, starting from the material assignment and the material window. We'll go back to the home page and double click on the engineering data over here. This is how the engineering data layout is going to look like. By default, we have the structural steel material. For this particular material, whatever the properties are there that are displayed over here, whether it can be related to the isotropic elasticity like elastic modulus, Poisson's ratio, bulk modulus and shear modulus kind of a thing. And on the right hand side, we also get to see, let's say we want to define some additional properties which we can visualize in the tabular form or in the graphical form. On the left hand side, we also get to see many different options of defining the property for the material most accurately, may be related to the life, strength, plasticity, elasticity, physical properties and so on. We discussed about the mouse clicks and the details. Then we understand a little bit about the coordinate system. Here is the coordinate system option in the tree where we can define the coordinate system as per our requirement, maybe Cartesian or cylindrical coordinate system. Then we go to the ruler and triad. Here at the bottom you can see a kind of a scale which is going to show the approximate dimensions of our model. Let's say we have this geometry. We want to understand what is the approximate size of this one. Let me change the unit from the right bottom over here, millimeter ton Newton second. So we can say that this particular geometry is more than 200 millimeter or close to 250 millimeter. Whenever we develop a mathematical model wherein we don't have the direct commands to measure the distance in this Ansys mechanical, so this scale is going to be useful for us. Similarly, in the display we can switch on and switch off the triad, the coordinate system that is over here. By default, the coordinate system will be at the right bottom corner, and this is just for the representation. The actual coordinate system is going to lie where the geometry, if at all the geometry has been created with respect to the coordinate system, where the coordinate system lies on the geometry, then it is going to show the exact location of that particular coordinate system. Under the display, we can click on over here whether we want to see the triad or not, switch on and switch off. Likewise, ruler, that is a scale that we discussed over here. Similarly, legend also can be switched on and switched off. This particular main window, graphics window, can be split into two halves, wherein in one of the window we would like to see what is the force applied, and another window we just would like to keep it as is. For our comparison purpose, then we can use this split window. Both the windows now are in sync. Once we rotate the geometry in one of the window, the other window geometry also is getting sync with the rotation, which we can switch off the sync so that we can handle these graphic independently. We remove the viewport now, keep it as one viewport. On the right bottom side or the center, we can see that for any of these line items, the tabular data and the graph data, we can see that the force is being applied from 0 to 1 second, that is 0 to minus 100 Newton, and in the graph we can see from 0 to minus 100, from 0 to 1 second, the load of 0 to 100 Newton will be applied. We discussed in detail about this tabular data and graph data when we solve the problem in the coming sessions. Now in the mesh tab we can define the uh, size of the element with a very good control, and also the type of the shape of the element that we wanted to achieve for this geometry. Then we'll move on to the next line item, that is help. There is a help option at the right top corner over here. The moment we click over there, click on the mechanical help, that will take us to the help documentation, wherein we can search the topic of the interest and get more information when we need it. This is the help. We can go by using this contents, or we can directly search the topic that we are looking for. This is going to give a detailed information of the topic that we are looking for. The next line item that we can see is about the settings, that is the analysis settings. Whenever we want to define the analysis settings like the time step or the load step, we want to have a better control about the solution, which we can control it in the analysis settings option. Solution information is going to give us the solution output files and the conversions, which we can monitor the ongoing solution and take actions based on those displays. We have covered almost all the content of this graphic user interface. All these options that we have discussed, based on the need, we are going to pick up during the problem solving phase and discuss more about it. The last thing I just would like to show is about the connections. Since we do not have any of multiple bodies over here, we may not get to see the connections in this option. I'll discuss more about that when we have the problem that is having the multiple bodies and understand more about the contacts or the connections. I hope this has given you a good understanding about the GUI of Ansys homepage and also the Ansys mechanical. You can be in touch with me to this number 9481635839, which is the India number. You can email me on caewwhelp@gmail.com. You can also visit my channel, YouTube channel, that is GRS CAD CAE. I will see you in the next session. Till then, take care and bye bye.